Greetings and welcome, friends. Mr. Waddy here. We are going over section 7.5, going over some of the homework problems. We were talking about trapezoids and kites. And it says, show that the quadrilateral with the given vertices is a trapezoid. So let's plot some points real quick. You guys are expert point plotters. So here's M, all right there, negative 2, 0. N is 0, 4, up 4 right there with the N yay. P is at 5, 4 over 1, 2, 3, 4, 5 in the up 4. No? Did I do it wrong? Oh. Yeah, I don't know. And then Q is at 8, 0 over 4 plus another 4. Looks like that is for the Q. So if I draw this trapezoid, they're asking, oh, show that it's a trapezoid. So what would I do in order to prove trapezoidalness? Show that exactly two sides are parallel. So it's not sufficient just to show one set. You actually have to show that the other set is not parallel in order to do that. Actually, I'll do this right there. What do you think? You guys think? Yeah, I think that's a good idea. Setting myself up for the next trick shot, like with pool. Actually, Mrs. Waddy, my wife, she's got some trophies for her pool playing abilities. Oddly enough, this is from her life before me. I understand the geometry of pool. I just don't have the dexterity to get it to do what I want it to. But that's fine. So let's see. The slope of NP is 0, right? It's going up 0 over whatever. It's a horizontal line. The slope of MQ is 0. So MQ slope is 0. Therefore, NP is parallel to MQ, right? Those guys are parallel. The slope of MN looks like up 2 over 1. So MN slope is 2. And the slope of PQ looks like it's going down 4 and over 3. So PQ slope, those are definitely not parallel, negative 4/3. So it is a trapezoid. Trapezoid. It's a trap, is what Admiral Akbar would tell us. I'm assuming. Let's see, question 7. Find the measure of each angle in the isosceles trapezoid. This problem gave you a fact in the directions, but it didn't label it here. Notice, because it's isosceles, I can actually find the other dimensions. Now, isosceles base angles are congruent, so that means the measure of angle J is also going to be 118 degrees. Because it's, let's see, what else could we do? Are these supplementary? Yeah, consecutive interior angles theorem, right? So the measure of angle L is going to equal the measure of angle M, which is equal to whatever's supplemental with 118. 180 minus 118, what is that, 62? Looks like. All right. I like these problems. The mid-segment of a trapezoid, even non-isosceles ones, will have a length that is the average of the other two. So I would say that 7, or the average of x plus 10, right, divided by 2 when I average those, would equal 7. Multiply both sides by 2. I chose this problem to go over. The other one's a little bit easier. You literally just take the average for question whatever I gave you. X plus 10 equals 14. Subtract 14 from both sides. And yeah, mid-segment is equal to the average. Nope. Subtract. Let's see. There we go. 10 from both sides. Minus 10. Like so. So x equals 4. But did they ask us for x? Well, I made that up. Yeah, so AB equals 4. All right. There we go. That's better. Right? Isaiah, you can take your headphones out. I wore my headphones today when I rode the mover to school. I was worried I was going to be late, but I rode the mover. My car is getting fixed today. It was. I actually... no, the 3.5 millimeter jack headphone. Yeah, it was good. Listen to some podcasts about science and video games. It says, find the length of the mid-segments of the trapezoid. I'm just gonna walk you through the idea. So whatever A, B, C, and D are, I would find the midpoint between those two, right? I would find the midpoint between these two. Actually, wait. Oh, no, not necessarily. No. I keep thinking of like diagonals, but that is not what I want to do. So actually, I do have to plot this. Man. And let's see, where should my origin be? Where do you guys fit your origin? I've got to go over at least as far as 12. Did I give us enough space? Yeah. So let's see. So the y-axis is here. And the x-axis goes as far as, okay, here we go, -4. So let's plot these points. A is 2, 0. A, B is 8, -4. All right, so A, B. C is 12, 2. I think I gave enough space for 12. Did I count that right? I should probably count it. 4, 8, 12. I did not count that right. There we go. 12, 2 is C, and D is 10, 0. 0, 10, my bad. Wow. 2, 4, 6, 8, 10. All right, so there's D. All right, yeah, I'm not going to be able to draw those lines myself. So, I've got to kind of look at this and figure out which sides are parallel. The mid segment is going to be the midpoints of the legs connected. All right, let's see. Come on, Mr. Waddy, speed it up. We got a test today. Students need to get ready for this test. I wonder if this is like a right angle there, almost. I don't know, maybe not. So let's see. It looks like these would be the parallel ones. They told me it was a trapezoid, so I'm going to just take their word on it. And then I would need to find the midpoint here and the midpoint here, something like that and that. But to find those actual coordinates, I would find the midpoint of AD and the midpoint of BC. The reason I had to graph it was because I didn't know which segments would have made up the parallel sides yet. So I would have found those two midpoints, and then they said find the length, and then I would have found the distance between those 2 points. Let's call this E and F. Right, I would have done an EF distance. What are your thoughts? Yep, alternative method. I could have found distance of AB using the distance formula. I could have found the distance of CD using distance formula. And then I could have found the average of those two would be the length of EF, would be AB plus CD divided by 2. But you guys have seen me do the distance and midpoint and averages plenty of times, so I'm just going to outline it like so. But that's how you would find that length. So a couple different options, right? The idea is that the mid-segment of a trapezoid is the average of the two bases' lengths. Let's see, here's a kite. We knew that exactly one pair of angles in a kite was congruent to one another. Since this is a quadrilateral, we know that all of those add up to 360. And so I would do, to find this guy, I'd have to, I'll call that x, I guess. So x plus 220 plus 60 equals 360. Subtract 60 from both sides, I'd get 300. Subtract 220 from 300. I believe I get x equals 80. Is that right for angle G? So measure of angle F is 110. Measure of angle G is 80 degrees. Right, so there you go. Kites. Hooray for kites. And let's see, 23. Give the most specific name for the quadrilateral. What are your guys' thoughts? This is definitely in the quad family. It's a rhombus by definition because it's got 4 sides congruent. Is it a square is what I'm wondering. I'm hearing no's and yeses. Isaiah, those headphones still can come out. Thank you. All right. let's see, what facts do we know about the diagonals of a quadrilateral? Or, sorry, a rhombus. They're congruent. Actually, yeah, check this out. If I just draw this diagonal, this is congruent to itself. This triangle and this triangle are congruent by side, 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 and then by corresponding parts of congruent triangle. Wow, I just blanked on the CPCTC. Corresponding parts of congruent triangles are congruent. Therefore, C is going to be congruent as well. Base angles theorem, these two would be congruent to each other because these legs are congruent. And therefore, these both have to be 45. Similar reasoning, those both have to be 45. This is a square. The amount of work to get there, though, takes quite a bit. Well, thanks for watching, Internet friends. Have a great day.